Hi there, in this You Try 2, we're going to look at electrical force. Let's share the screen here so we know what the problem's all about. So, a small metal sphere with a negative charge of 2.10 times 10 to the 6 coulombs is brought near an identical sphere with a positive charge of 1.50 times 10 to the 6 coulombs, so that the distance between the centers of the two spheres is 3.30 centimeters. Calculate the magnitude and type. I've given you it's either going to be attractive or repulsive of the force of one charge acting on another. So your goal is to actually figure out the actual force that is dealing with in this problem. I'll give you a hint, it's electrical force. And in that, you also have to say attractive or repulsion. Think about negative and positive. What do they do as charges? With that, in fact, we should be able to pause the video and actually work on the problem. Once you're all ready to go, then press unpause and you can watch the rest of the solution. Keep in mind, I'm going to be using the grasp method, just like your textbook. G for given, R for required, A for analysis, S for solution, and P for paraphrase. Please pause the video. Once you're ready, unpause and check your answer. You will realize that under the given, we were given three quantities that are here and one as the constant. So the Q1 is 2.10 times 10 to the 6 coulombs. Q stands for the charge of the coulomb. Charge 2, 1.50 times 10 to the 6 coulombs. We do not have to put negative or positive, representing that they're negative and positive, because at the end of the day, we will realize that it deals with just attraction and repulsion. The K represents the constant that the question, that every electrical force has. And here it is, it's times 10 to the 9. Keep in mind, meter squared, Newton times meter squared over Coulomb squared. So that means our radius, which is really our distance in this case, from one object, which is this sphere, from the other sphere. So what's going to happen is that how we're going to cross out centimeters with meters. We need to convert that. As we know, there is 100 centimeters in 1 meter. So we would have to divide, like the following. We would do a conversion factor. There is 1 meter in 100 centimeters. So when you write it in this format, what's going to happen is that centimeters cross out, and you're left over with 3.30 times 1 divided by 100, which is the same thing as saying, if you look in your formula sheet, it tells you what a centimeter actually is, times 10 to the negative 2. Negative 2 meters. Okay, so with that, in fact, now we have converted our distance. So let's look at the required. The required in this case is dealing with a force that is dealing with electrical force. So now keep in mind, we like to have, it's a vector quantity, so in the end of the day, we're going to have attraction or repulsion. We also know that it is absolute value. So that's what these lines going up and down mean. That means if you did incorporate the negative and the positive sign, end of the day, it's still going to be not needed because of the fact it is a force, and a force can't be negative. So in our analysis, let's get down to business, where we're going to rewrite the formula Fe equals 2K times Q1 times Q2 over R squared. Now keep in mind, R squared needs to be considered, because if you don't square it, it's usually a distraction on a diploma. So make sure you square it. Okay, so now what is our value for K, which we have right here? And we're going to start putting that in first. Then we have Q1, which is charge 1 of the metal sphere. And then we have sphere 2 has a charge, 1.50 times 10 to the 6 coulombs. And we're going to divide everything by the distance, which is r squared. And we came up with earlier, as we said, 3.30 times 10 to the negative 2 meters. And let's start putting the brackets in just to represent that we're multiplying the top values all together. I left the units in there, so we're going to cross them out right this moment. So meter squared, and here's our meter. Oops, forgot the square right here. So now that crosses out, that crosses out. Divide by c squared, which is c times c. So that crosses out. And we should be left over with newtons, so it works out nicely. So when you do your calculations, you're going to get 26.004 ... That just represents that the value keeps going on and on and on. Under my solution now is where significant digits are a factor. 3, 3, 3. So our final answer should be 26.0. So F E equals to 26.0 newtons. Here's the important bit. Is it attractive or repulsive? Well, if one is positive and the other one is negative, so here's the negative one, here's the positive one, end of the day, that's attractive. So because attraction comes from two different negative and positives. So in that case, what we need to also say is attractive. So now that leaves us with a paraphrase. Now keep in mind, in our paraphrase, we need to actually indicate what happened in the problem. The two metal spheres have an electric force of 26.0 newtons, and they are attractive to each other. Hope this answers all your questions to this problem that you tried to. If there's any questions, don't hesitate to let me know. Have a great day.